Vítam vás. Máme tu tretiu prednášku, ktorá taktiež z architektúry softvéru, ktorá tiež bude v angličtine. So, welcome to this lecture. We continue with design patterns we talked about previously. So, what I wanted to tell you before I start with the lecture is to attract your attention to this list of lectures where you have also literature introduced. So some literature is labeled as reading, some as references. Not all literature is actually literature because some of these are videos. So I guess this may be kind of really fun to watch. Nevertheless, I think the reading is also amusing. So I would like you to actually have a look at these things, read them, like study them. I think that there's not that much reading because it's not like whole books that I'm imposing on you, but there are some parts of these books like sections, even kind of not even whole chapters, but some sections or subsections that I would like you to read. One thing is that we have this lecture and I talk about some things, and these may be like presented in one way or in another way, and I may forget about some things, and I may leave out some important things and so on. But these readings are really kind of what gives you another level within this course and in any course. But the reading needs to be specific. So please follow what is presented here and read these things. Actually, I urge you also to, at some point in your life, you might return to these things. Maybe not for all. This will be kind of for all of you. This will be valid at this moment. But there are things like Christopher Alexander's The Timeless Way of Building, which is really nice reading, and you would see that there is a way to read this book in only 2 hours or so. Alexander emphasized the parts of the book to be read for a quick read, and nevertheless, I think you will be attracted to read it completely. And if you just forget a bit that it is about building architecture, you would see how it is really applicable fundamentally to our field and such things. So I reordered the lectures a bit as I mentioned. So we are here currently, lecture 3, and I think I will leave this like this. I have to think a bit more about this, but we might have a break from patterns then and have a look at how UML can be used to express architecture, software architecture. Yeah. So what are the possibilities? Of course, you can put some classes, some interfaces, and express your architecture like this. But there are some kind of underused parts of UML that might offer or might be more expressive for these purposes, and might pose less limitations, because when we draw classes, we are limited to think in object-oriented programming way, and to to see really these classes as classes, while sometimes we need to operate with higher level modules. So that's the plan. Anything you want to ask about the last question, last lecture? I did not see any unclarities indicated in the form. So if there is anything we should get back to, let me know. It doesn't seem so. So let's try switch to this lecture slides. Today's lecture is about selected design patterns from Bushman's pattern-oriented software architecture and their composition. So the focus will be on how are we combining the patterns. I indicated something along these lines already in the previous lecture, but we should have a look at this kind of in more detail, I think. So let's start with an example. This is a description of a warehouse management process control system from Bushman and colleagues from that one of the books that from that series of pattern-oriented software architecture books, and this is exactly volume 4. I think if you have limited time and you won't even kind of you don't want to lose any moment, I think you should go directly to this volume, like volume 1, 2, and 3. Especially volume 1 might be more readable if for like if you come from the Gang of 4 perception of design patterns. But if you are interested, especially in distributed systems, this might be like a really good reading, and it actually comprises improved versions of the patterns presented in previous volumes. Volume 5 is also available, but it is about more maybe advanced things. It might be kind of a good reading after volume 4, or looking at volume 4. It doesn't mean that you need to read all of, I don't know, there are some 112 or 17 or something like that, 112 I think, patterns described in this volume. These patterns are not invented by Bushman and colleagues, his co-authors, but they're collected and observed, and many of them are actually have been published previously, and like you might say that this is a kind of a repetition, but it is not, because in this catalog and actually pattern language presented by Bushman and colleagues, much attention is paid to how patterns are to be composed. What are the possibilities? And there is a long discussion in each and every pattern presented there on how these patterns can be composed with other patterns. So let's get back to this example. So we have this warehouse management process control system, which is a large set of integrated and effective administrative and operational domain functionality. Can differ between different instances of the system, so that there can be different versions. Requires an appropriate infrastructure for inter-process communication, persistence, logging, etc. The system's functionality must be easily accessible by both users and systems that reside at the operation level. So, what kind of architecture might be good for something like this? So this seems to be like a big system might be distributed over several nodes, computing nodes, because there is not enough power for computing power at one of them, if you think of it. That's one thing, so we might go for some distributed architecture, but looking at the third item requires an appropriate infrastructure for inter-process communication, persistence, logging, etc. Like, we must kind of understand what the system is. Of course, now, like, I've put you in this position to decide this for this moment, but in reality, we would be speaking with the specialists, with the domain experts. So for warehouse management. And we would understand that the complexity, and we already collected this requirement, and we see that it seems that these are like things that depend on each other, or one thing depends on another, and we want to reduce dependencies. And we want to build this system gradually. So maybe this inter-process communication is one thing that we want to have, but we want to have also persistence on top of that. So we might think about this system as a kind of a layered system. And there is indeed this layers pattern. I think I did not show this to you last time, but I mentioned the layers. So what, like, you might kind of not know about these things, but that's why you are going to read something from that Bushman's pattern-oriented software architecture in order to understand what are the possibilities, and if you would be kind of in a position to select a particular architecture, and maybe as a young architect with no one to ask about, or being embarrassed to ask questions somebody else about this, which you shouldn't be, actually, you would look in this book for the possibilities of setting up the system. So we don't have time to go through this, but check out the other. I will mention, we mentioned last time, and we'll get back to this pattern even in today's lecture, model view controller. So you must start from something. So some pattern would be your basic pattern, and there is even a pattern of like something like called MUD, or like unstructured design, or monolithic design, where you like put everything together. It's all like heavily wired, mixed up, and you get on with this to some extent. And for some purposes, this might be a viable solution, although later you might as the system evolves, you might like to get to some more structured form. So then you restructure this, or as we say, refactor this. But if it's possible, and if you see that a more structured approach could be applied, then probably you should go with it. So you might find, like based on this requirement that I mentioned, that you should have like inter-process communication, logging and persistence, and different layers, like layers. It kind of might switch a small light in your mind that this could look like layers. And indeed, layers, when you look at this pattern, so you open it, the description of each pattern is like spread over several pages, text, and sometimes diagrams and so on. So it's not easy to go through all this and understand all the details at once, but you should always look for the basic meaning of the pattern, and then for the details, look for the details. And the basic thing that you should look for is what conflict of contradicting forces does this pattern resolve. And this is roughly after the like introductory text. Just after that, you will find at the place where the problem is indicated, that it is indicated as a kind of a conflict of contradicting forces. And I also squeezed this even more into this. Always tend to squeeze these forces into two most prominent contradicting forces. So here, for layers, it is that parts of a software system need to be coupled in order to provide the overall functionality, but they have to be developed and let evolve independently at their own pace. So it is not, let's have layers, but we are pressured to have parts of software system which are like interconnected with each other, but we need to decouple them sufficiently so that they can be maintained in their own way, to say so. Many different ways of expressing these forces are possible. We can even reverse them, or I don't know. So it's not a dogma. It's the way that we perceive things, think of the thing, of this thing. It's like having a geometric object or something alive, really, and you can look at it from different perspectives and start talking about it from different perspectives, but you should come to the essence. And you can express it in different ways, but the meaning, you will feel that the meaning is the same. So I urge you to look in the Bushman's book how he described layers, and compare his description to what I extracted from there. And a pattern always offers a solution. So there is a problem, this is a conflict of contradicting forces. The resolution or solution is to arrange the layers hierarchically, letting each layer depend only on lower levels. So this is a system that by experience, I wouldn't say guarantees, or like tends to decrease the dependency between the layers, and to provide sufficient order so that we can maintain the layers independently. That's how we know that this works, from experience. We might come or prove, or like logically, or maybe sometimes even mathematically, that this holds. But usually we will go through many examples. We will select different examples and explore how does this apply and what are the properties and so on. Because this is a complex thing, so it is not easy to approach it like in a formal way. One thing spoils this short description is that, and it is that we talk about parts in forces, and then in resolution suddenly we have layers. It is okay for a pattern to construct something. And as we saw the description, if you recall the description of model view controller, there is model and there is view in the description of forces there that I introduced to you. But there is no controller there. The controller is kind of comes into play. It is being introduced as a part of the solution that is constructed by the pattern. Each pattern always constructs something, generates something. So it might generate further parts or roles as well as to modify them or to kind of impose some features on them, to change them. But in the original, their original meaning, the roles occur often in this forces part. So these parts there, we might have called them also layers at the very beginning. I think it wouldn't spoil anything. So we shouldn't talk about parts. We know that we are talking about layers. So it is the layers pattern is not that we don't understand or we don't know that we are working with layers, but it is about how dependent or independent the layers are. Maybe we could then discuss the name of the pattern. So the name of the pattern might be something like decoupled layers or something like this. But then that would be kind of a longer name, and some names are good because we are used to them and such things. So this is how it is with the natural language. But these things are always good to think about when you look at patterns. So that's why I'm talking a bit longer about them. So if we look at our example, how can we organize our layers, it could be like this. This does not come out directly from what I said about this system, but it would come out from further analysis of the requirements of the domain, talking to domain experts and so on. So I don't want to pretend that I derived this. Okay, I saw this pattern and I saw the picture before, and then I improved it because I read the pattern like this. No, this adds further detail, but it is useful for us to look at how dependencies are maintained, like strictly that between these layers. So starting from this access layer up to this presentation layer. So the presentation layer, nothing from above calls anything in the presentation layer, to say so. So these connections represent some kind of navigation. So these are, what are these elements in UML? For those who are familiar with UML, what are these elements? Do you remember? No? These are packages. These are actually packages. These are not classes because packages have this kind of rectangle for their name, and when they are shown like without, you could have a package. Maybe I will manage to draw something. an example. Why this starts? This is not what I wanted. It was somewhere there. It's always different. I don't remember the name of the tool that I used to draw things. It's kind of a notepad or something like that. And it was like, Windows Journal. So it's like, let's make it bigger or even bigger and change some colors. And so something like this. So you could have like my package and some classes inside. Somehow connected. You could have something like this there. But when you show a package, just a package like without its contents, then you can put the name there. And but why would you put packages here? These are like more like, so these are not classes. These are like bunches of classes or sets of classes, collaborating classes, and it's more like components there, more like components. But sometimes packages are, and this is like more historical thing. Packages were used for this. So we will discuss this more thoroughly in the next lecture. But just for you to understand these things, and what are these rectangles like this in UML? These gray rectangles that represent different layers. Does they remind you of something that you saw in UML? Borders? Are there borders in UML? What are borders in UML? They shouldn't remind you of anything, apart maybe in UML diagrams if you meant the subject. Yeah, okay, but these are not use cases. So there is no such thing in UML. So this was meant as a joke. So it's not, the notation used by Bushman and colleagues is not quite, UML, they explain though their notation, so, and the notation, UML notation evolved and evolves over time. So if you look in older books, you might even find even stranger symbols. So we should get used to them to understand the book and so on. They could be transformed into the proper UML, but it really doesn't matter. UML is good to be kind of as a readily understandable notation between specialists in our field. So that's the most important thing. So these packages, actually, when I say that they are actually domain objects, it would be even more confusing. So these packages, these domain objects are the objects that we can decouple the domain into, like domain entities or something like that. And they are more about data than about operations, but some of them actually might be rather functional units, I guess. So there is a pattern that helps us with establishing domain objects. And it says that domain objects need to be interconnected, but they tend to be highly interrelated to the level of losing own boundaries. So, in order to know, you've heard probably how high coupling is bad. Coupling, like coupling as have cohesion and you have coupling as a property. But high coupling, actually some coupling, and often you cannot avoid really high coupling, is unavoidable and is present in highly successful projects and systems, and it really does not pose a problem there. All the while you manage to have it under control. So it's not a wild coupling, but you must know where can you avoid it, where should you apply it, and so on, and what kind of independency can you achieve of your domain objects. And otherwise, everything will be interconnected to the extent that you could not recognize individual domain objects there. So domain objects are representations of the domain from the domain of the objects in the domain that we address by our software system. And the resolution that this pattern brings is to make domain objects as independent as possible, communicating over well-defined interfaces. So it seems like, okay, but how can we do this? In many different ways. So you might be kind of limited or in perception of patterns by what you read from or in the Gang of Four patterns, and with the exact examples of, I don't know, observer or whatever pattern, so that you might think that there is always an exact scheme of code that should be applied, and this is how it goes, and you cannot apply it differently. And in Java, it's like this. In C++, you have this implementation. There are lots of sites that offer, and even in the Gang of Four book, you can find these implementations as well, offered as examples, and they are very useful because going through this implementation, that's the only way I managed to understand actually what the pattern is when I was reading this book. So I advise you on trying and exploring these examples. That's very good. But the idea behind the pattern is usually more general, and this solution is meant to force you or direct you into some way of thinking that will engage your programming capabilities to achieve this. Because when you understand that you are going to try to separate these objects, you're going to find the points within these objects that are addressable from the outside world and others are not. And given the language that you're using, imagine that you're using Java without access modifiers. So there's no way for you to hide the implementation inside that you have there, but you can introduce some regulations, some rules, some sort of some nomenclature or naming conventions that will help not mix up things too much. So it very much depends on the solution domain, the programming language, and the frameworks that you're using. And the pattern might be still applicable. So that's the first line. But then, when you do really have some possibilities offered by the solution domain, you might think like this would be the thing, the situation with this pattern, like the first line of this pattern or the first approach, the initial setting. So you put these organize these domain objects and you have like units within them which still might not be represented as classes but as some more complex components. You have different things like this is receiving, this is order management, stock management, shipping. Not all of these things should be connected to the outside world, and the same thing here. You have here, this is even more obvious. You have global routing, and then different kinds of routing. So probably this will be the access point for this domain object. So and you set the boundaries of, but this pattern is mostly about setting the boundaries between domain objects. So you know what warehouse management is about, and you know what material flow control is about. So further, if you want to manage the dependencies between these domain objects, you should think of establishing explicit interfaces. So that's what I started talking about. Just even if you imagine you don't have access modifiers to hide the implementation, which is actually not important for establishing explicit interfaces, or even if you don't have interfaces. Like if you have interfaces, probably you will use interfaces for this, and your classes will realize some interfaces. Like you have a class that realizes a certain interface like this. So this is an interface, this is a class, and a class that realizes that interface, and then you have a class which is a client class, typically denoted as a client class that uses this interface. So there is no dependency between the two, but sometimes you cannot introduce interfaces, and the thing is that you should kind of introduce some particular methods which are like to be called from the outside world, like maybe this method M, but this method X is not your access point. So this is something to think about. And there are different ways of resolving this, depending again on what the solution domain offers to you. One step further is to introduce encapsulated implementation. Again, the way that you can introduce it. So here we should have probably set this method as private. No, this one will not be private. This will be kind of public, and this one private. So these are the things that you can think of and use depending on what you have in your domain. So a component offers its services through interfaces, but its internal representation can vary over time. So you need to ensure that the component internals remain hidden, allowing the access only to its interfaces. Again, how do you do that in a language that does not support any information hiding or encapsulation? You must introduce some conventions. That's the only way, and you cannot implement this directly, but you must rely on people to understand that this is necessary and this should be done like this. But where you have access modifiers like private, public, sometimes this is like protected and package access like in Java, but there are different ways of different systems of access modifiers. These are of help to implement these patterns. So these design patterns tend to be independent, like generally applicable to different programming languages. And it's always that you do as much as you can, not more than that. That's a joke, but you can't do any more than you can do, of course. So let's move on to see how this could look in our scheme. And we see here these interfaces. So these are like these connectors, like this is this lollipop notation. So actually here, if I would put this interface, the same picture could look like this. So this is the interface I. I can even mark it like outside like this. So I. And then I have some line to this side and to this side. Some edge. Okay, so this would go to client. So this is a kind of a different. Maybe I should have used different color to emphasize that this is something different. So what should I put here and what should I put there? So this is the notation, this lollipop notation. Do you recall this notation from UML? What does this side mean? So there should be some class and some other class or something. Some component, to say so, in general. What should be there? Or which kind of ending? Should I prolong this here or there? No idea? This is it was meant to kind of look logical. So this is the provider of the interface, like the one that implements the interface, the one that provides the interface, to say so, realizes the interface, is more tightly connected to it in this notation or directly, like exposing the interface. So this is a kind of an interface of this class. It could be also an interface of some other class, like this. So we could have different classes that realize or implement this interface. But anyway, this lollipop notation limits us to one class because it's meant for such nice schematic pictures, like where you don't have really indicated not even what these interfaces are. There are no names. There's some like idea that there should be some interfaces. And then the other side looks like this, like the one that uses the interface. So like you are, the idea might be like the metaphor might be that by this class you provide the missing wheel to the client. Anyway, so if we get back to this picture, so we see that Now, Bushman and colleagues introduced freely classes into this set of symbols that they use, and these classes represent more like components. These are not these are named as interface classes, but these are not really interfaces in the sense of Java interfaces. Although Java interfaces in modern Java can have some sort of implementation inside of them. These are meant to be more like classes that implement the necessary functionality to be exposed to the outside world, and then these interfaces are really exposed like this. So maybe a set of classes and interfaces in Java parlance, or abstract classes in C++ or something like that in different languages. So here we combined actually two patterns that we had previously here exposed, and they go hand in hand very well. Explicit interface and encapsulated implementation. Because this one does not, the first one does not protect what's inside, and the second one does exactly that. And we need both of these things in order to have a fully functional, previously exposed pattern of domain object. So a domain object then is elaborated by these two patterns further. And we came to domain object from the layers design pattern. So the overall system design seems to be driven by hierarchical pattern composition. Something like this. So for now we have layers, domain object, explicit interface, but we also have this, where do we put encapsulated implementation? Should we put it under domain object as well? Or how did we apply it? Or is it related to explicit interface? Isn't it related to explicit interface? It is actually quite combined with explicit interface. So it kind of suddenly doesn't seem right, like this becomes not really hierarchical composition when we consider encapsulated implementation. So we might indicate that this is interrelated with explicit interface. Which comes first? Encapsulated implementation or explicit interface? Like if we follow the order or we might say that we first applied explicit interface, and then modified the things to have encapsulated implementation as well. But this is no longer that hierarchical. Which one is more important? We could have implemented first encapsulated implementation here and then go for explicit interface. So we somehow compose them, these two patterns, as kind of peers. And we compose them based on their roles. So on one side we have component and its interface, which is made explicit by this pattern. And on the other hand, we have component with its encapsulated implementation. I think there is no other role in this pattern. But these two roles, component and component, maybe they could, in some cases, they could be named differently. are actually interrelated and composed and represent one thing. So this pattern adds something to component, and this one adds some features to component, to the component role. And this is one thing, and the interface is the other thing. So it's kind of that we have some responsibilities for a role coming from one class, from one pattern, and then we superimpose further responsibilities coming from another pattern. So I would say that this is more like a peer-to-peer decomposition, and this one is like hierarchical, and actually you don't exactly you tend to kind of elaborate roles, like you actually further decompose the roles or reorganize them by this hierarchical decomposition, because in this pattern you have layers and you don't have domain objects exactly there. So the domain object layer decomposes the layers. So this hierarchical decomposition applies whenever this is the situation. But when you have these combinations of role responsibilities, this is more like peer-to-peer decomposition. And you might say that really this peer-to-peer pattern composition is based on role superimposition, putting roles on top of each other, to say so, like the responsibilities of the roles. I'm not trying here to overwhelm you by a number of patterns and to explore a number of patterns and quickly switch from one pattern to another pattern. I'm rather trying to explain you how can you cope with that number of patterns that you will see in the Bushman's book and some other books and some other literature, and what to look for when applying them. And I think by now you have a bit of a different feeling about these design patterns than when you thought of Gang of 4 patterns. So this is not an occasional application of a pattern. This is a systematic way of applying patterns, like systematic way, like thinking in patterns, establishing the whole architecture in patterns as design decisions. And if we put a diagram like the one I showed in the previous slide, like this, we put this diagram together as a sequence of patterns that we applied, we might share this sequence along with the story behind this sequence, and that story is called a pattern story because it is about patterns. If we share this with somebody and actually do not put too much detail there, then that somebody could make use of this and apply this, maybe not exactly in this way, but might perceive this as a kind of an extended experience. So not of just applying one pattern for some particular occasion, but a whole set or sequence of patterns, and this can be applied to similar settings on and on again to build similar systems. You might say, why? Okay, if they want to build a similar system, let's take that code and just transfer it to the different setting. or to the different context. But that context might be kind of really different. Might require you to use a different programming language, different framework, different slightly different requirements you might have there, and many other things. And to reuse code, you must understand it. So you must go into deeply, like in code, it's like, okay, this is a nice building, which might be to some extent, maybe to the great extent. I wouldn't think Christopher Alexander would be happy with this building. So if you have a building that you're satisfied with, so you don't really like decompose it into bricks and the elements that it is built from, and then set another building exactly like that. And over time, the material evolve. Like there are always like better materials, better building elements that you can use. That's exactly in our domain as well. But like in some 10 or 15 years, or 20 years, even longer time, pattern sequences might be useful for others to read them, to consider them, and to kind of speed up the design process of their own systems. So let's move further a bit to yet another pattern. So now first I will show you a pattern, and then we will discuss its application. It might go this way as well. So you might like be happy with the development as it goes so far, and you might remain happy not knowing that you might have done something in a better way. Maybe if you want to stay happy, so that's kind of a way to go. Close your eyes and remain with what you know, and do not listen to anything else, and you will remain happy, because you will think that there's nothing better than that. But we want to be competitive, we want to be to improve things and so on, and we know that there is some wisdom somewhere. It's foolish not to have a look, and it's easily accessible. It's foolish not to have a look there. So the other way of using patterns is that you really learn about them. So you just go through the book, through some books, some literature, and occasionally actually follow some papers. As a software architect, software developer, software engineer, whatever label does fit best to you. Domain, even domain experts could consider these things, and you actually, a programmer, why not a programmer? Why it became like an obsolete word, and we use software developer as instead of it. You could look into patterns, you could look into different patterns and be informed what is happening, what is being discovered, and what solution, even not just individual patterns, but sequences of patterns as well. They're always interpreted as parts of sequences in good literature. And you might come across one such pattern because, and it does not need to be accidental. You might be heavily interested in distributed software systems. So broker is one pattern that can be used, that's very helpful in establishing distributed software systems. It says that remote components in a distributed software system need to communicate but this is complicated by technological dependencies. So the problem is that you must know what a distributed software system is. It is the one that runs over on several physically independent computing nodes, like machines. So you have, it's easy to have a program on your own machine, but imagine like having some part somewhere else and another part elsewhere and so on. And this might be even dynamic. And dynamic allocation might be involved with this and so on. But the first problem that you will encounter is that calls to procedures, whatever kind of procedures, methods, on my local system look different than calls to the remote system. So I have to somehow forward the calls there. And if you remember in Java, the serialization was not meant to that much for saving the data that you have in your program, for the persistence purposes, as to transfer arguments to the other side. So you put that in one file and you transfer your arguments, which might be complex objects in their own right, to the other side, and you use them there. And it can go like byte by byte. So that's why it's serial connection. A serial connection is enough for this. So that's the thing that we cope with, but we don't want things to look that bad for us in our daily programming. So we in order to compensate for this complication, we introduce a set of brokers to hide technological dependencies, making remote component communication look like the local one. And it might look like this. So here we have this famous network, which is another non-UML symbol introduced here. And we see that we still have layers here. This is interesting. But these layers are actually running on different machines, different computing nodes. And to interconnect them, we use these brokers. It's always that one, as we learned from the layer pattern, because layers are hierarchically organized, then one naturally serves to fulfill the services or to provide the services for some other layer or layers. So it's only natural that we have this, we came to this client-server architecture by the way. So you might say, you might have heard, and actually I doubt that anyone is here who haven't heard about the famous client-server architecture or client-server style. But what exactly this style is, you don't know until you go inside. And you can go inside particular classes, particular objects, and how they are organized, and everything, and you might go inside by following the design decisions, and this is this way through patterns. So we are looking at this client-server architecture by applying this broker pattern here. So the broker the brokers actually hide away. So you actually do not talk to the other side. You talk to your broker. And when you have some financial papers, some actions, some things like this, you don't sell them on your own. You talk to your broker, and they arrange these things for you. It's too complicated for you to go to the stock market and interfere with all the complexity that is there, but you also would like to invest something somewhere. So you engage a broker. So the same thing from the other side, and these brokers are somehow connected. And that's where, in this bidirectional arrow, the complexity is hidden, and inside of these brokers. You can also notice that here we have some proxy elements displayed as classes, but maybe these are rather components. So these are this is another way to further elaborate dealing with this complexity. And these proxy elements are actually here to stand for many other elements here, even from the side of this broker. So this broker is just, this server-side broker will not go beyond these things. So you will not see these things. It will imitate something like this. So this is the client proxy pattern. And this is I do not have this pattern described, and I like to discuss it explicitly. But this might be an opportunity to recall that the Gang of Four also includes their catalog includes the proxy pattern. Do you know that it does? Has anyone heard of this pattern? So you must believe me at this moment that yes, there is such a pattern. It's called proxy, and this one is called client proxy. And there are other proxy patterns, which kind of specialized proxy patterns. How are they related to each other? This is another important relationship between patterns, which is often neglected. And that's generalization, specialization. So, or something along these lines. Or let's relax this further. There are different versions of the same pattern, slightly adapted to the context differences. But the idea, the fundamental idea, is the same and might be even expressed as in a general form. But often no one bothers to do this, because patterns almost always live just nearby the actual work, where the actual work is done. So we do not bother too much in patterns or to define different. It's just like with use cases. When you have use case modeling, you can imagine, I don't know, what kinds of use cases that describe your system at a very high level. Even the overall system might be a use case for you, consisting of the actual use cases, to say so, user level, user goal or user goal level use cases. So these are the use cases that we are interested in, that enable us to really understand what needs to be supported and how it is to be supported. Other things seem to be too general and too abstract necessarily. That goes often hand in hand. So the same with patterns. So in the literature you will find different versions, and maybe really like patterns of kind of really different names might occur. I think in the lecture on distributed software development or distributed software architecture, I have this example, but more elaborated. But I'm not going to switch to those slides now. Now I will just mention the similarity between observer and publisher-subscriber. If you look in the Bushman's book, you will find that these patterns can be distinguished, but also that like they seem to be kind of very, very similar. They have very different names: publisher, subscriber, and observer. You might guess when you analyze these names thoroughly that there might be some similarity, but probably you wouldn't do this. So this is how patterns are related in very different ways, and usually for your own system, for your own development, you pick and choose different patterns, and you actually they become the elements of your language, and your dialect within your organization usually. And you maintain some understanding of these patterns within your organization. You might understand to some extent, like there are many languages that are understandable. So the speakers of one language understand the other ones, the speakers of the other one, and so on. To some extent, this holds also for patterns. So you will form your pattern language within your organization and your versions of patterns. That's normal. So the things somehow develop in mysterious ways with patterns. So this is the broker pattern, and we see that this broker pattern, I've put the layers. Actually, I'm using the figures from Bushman and colleagues from POSA 4. So you see that they've put these layers there, but you wouldn't have to have. It's not necessary to have layers actually here behind these brokers for the broker pattern to be applied. But it can be really combined, easily combined, and it goes hand in hand with the layers pattern. So this is one interesting thing to observe. Actually, this complex application of this broker pattern might even require layers. So this is the whole picture, which is way more complicated. So just to have a look at it and where the things are. And yeah, I actually unrevealed what I wanted to ask you accidentally right now. Sorry for this. But let's reverse it. There is also model view controller hidden in this picture. do you see it, and by what you would say that there is model view controller there? So look at this scheme, this picture, this diagram. By what would you say? You might also say opposed to this assumption that there is model view controller applied there. So what would you say? By what can you tell that there is model view controller there? Model view controller is easy, you recall it very well, and you can recall it easily by just looking at the name of the pattern, unless you shorten it to MVC, which is difficult to understand if you don't know what is hidden behind these letters. But I've written model view controller, so there should be model, there should be view, there should be controller. Look at this layer, the above. It's called presentation layer. And this one here is called business process layer. Aren't these business processes a part of what we call a model? So it's just a different way to name the same thing. Business process layer, business processes, or whatever. So there are some data there, and but most of all some processing procedures or algorithms, whatever. Activities, business activities implemented there. This is your model, and it should be presented in different ways. So the presentation layer is your view, and you can see that actually there are different views that should be managed somehow. Something goes to one, something goes to another view, and such things, and then there are responses that should be provided to the other side, and so on. So the controller logically comes in between, to say so. Has anyone came across a model view controller as layers? Anytime. Like sometimes you will, if you read different literature, there are different approaches to what to explain the model view, whatever it is, model view architecture, model view style, and so on. Trygve Renskaug, who actually came with this pattern, denoted it as a pattern, but you might call it different ways. So you might see a model and a view model. Maybe it's better to. Can I delete this somehow? I don't know. View. I must learn how to use this. View. Model and the controller in between, and we can start drawing arrows as well. So some idea of how this could be perceived as layers even. I think it's a bit difficult to perceive completely this as layers. Like if you have these brokers, then this is easier because these brokers are not exactly a layer or layers. But anyway, sometimes they talk about, in literature, some authors, about the view layer, the model layer, the controller layer. So this is kind of like it is these patterns, like model view controller was not observed first in distributed software systems and not perceived as a layered structure, but there is something to it inherently, it seems so. And based on this inherent similarity or archetypal similarity, it might be that these patterns are, we can connect these patterns or put them in relation. If we get back to this model view controller user pattern, because it involves also the user. So previously we had it expressed like this. The system has to comply to the user's mental model, but this requires coordinating multiple views over complex data. So I think I already changed this in the last lecture, but also I would say that we might correct this complex data to complex model, so to understand better what is it about. And the controller part, as I mentioned, is actually constructed by the pattern. So this is, I actually already explained this thing. So just to remind you of this, that patterns are sometimes, they always introduce, they construct something, and sometimes these are like new features or relations between the roles. So they enhance the roles. Sometimes these are new roles as such. So if we get back to our scheme, I don't really see that the layers are subordinate to model view controller or vice versa. Let's get back to the picture. So if you look at this picture, I don't really see, maybe you do see that, so give me another opinion. So I see that these like and the model view controller is used here to organize the overall system. And we already learned that model view controller is one of the patterns that we can kind of start with for the whole architecture and then develop it further, work with details. And layers, the layers pattern is also one such pattern. So like to say top level patterns, which might be perceived as architectural patterns or architecture patterns or whatever, like the high level patterns that then you elaborate further with some smaller patterns, to say so, more specific patterns. And I don't see how, what came first, like is it layers or is it model view controller? So I put both of them at the same level, just like explicit interface and encapsulated implementation. maybe then this edge, you might say that this is a composition, so this edge should come out from this composition. But somebody might say that, okay, it's not that model view controller is decomposed into domain objects, but the layers are decomposed into domain objects. There might be different perceptions of these things and these relationships, and these pattern sequence schemes are always limited. And one of my PhD students explores the ways of interconnecting patterns, and he does this with organizational patterns of software development. But this is applicable also to other patterns, most notably to our design patterns. And there will be shortly, like if for you who this applies to, there will be shortly the master's thesis topics will be announced, and one of the topics will be related exactly to this. Not to say that you could explore this way of presenting the relationships between patterns. So not to make this too much complicated, but maybe a bit more detailed, a bit more clear with different relationships or combinations of patterns, so that as much as it is possible can be seen from such a scheme, yet that it remains still acceptable to people to look at it, and not to just for some kind of notation development experts to write papers about this. So a practically usable thing. So you might try something like this in your software architecture project as well. So I would say that main architectural patterns can be also composed on a peer-to-peer basis, is the conclusion that comes out of this part, the last part. And I think we can close actually the lecture like this. So that there is plenty of time for your questions, so we can discuss anything related to this lecture, or we can get back to anything that we talked about in the past lectures, and also if there are any questions or things that you would like to discuss about the project. So it doesn't seem that there are any questions, anything you would like to talk about. Okay, then I don't know, I will remain here for individual consultations, of course. So that's it. As I said, we continue if I don't make up my mind or do not hear from you otherwise. So you can see what is available there, and there might later there might be one or two additional topics not presented by me, by guest lecturers. So you might see that here. We have lean architecture, people and architecture. This is again about patterns, and then distributed software architecture. We will get back Mostly to these things that we talked today about, and explore particular architectures, or what is appropriate for distributed systems. So this lecture also contains some things, some material related to this. The examples were based on distributed system development setting, but this is specifically about distributed software architecture. Not everything can be presented at once, so maybe I'll be moving these things like now as I think of this, teaching this course for some time. Maybe I would move this distributed software architecture closer to this lecture, so to have kind of a closed topic related to distributed software architectures. But I don't know. So if you have some opinions that you would like to hear first about something else, so just let me know. We can discuss this, and I think we can easily reverse the order of the lectures. Okay, so that's it. Thank you very much for your attention, and see you next time.